Good morning students, welcome back to 9th Science, Unit 12, Periodic Classification of Elements, Part 1. Now come to the learning objectives. To know the concept of classification of elements in early days. Understand the postulates, advantages and limitations of modern periodic table. Understand the classification of elements based on the electronic configuration and learn about the position of hydrogen in the periodic table, and to study about the position of rare gases or noble gases in the periodic table, and to distinguish between metals and non-metals. Come to the know about the metalloids and alloys. Now come to the introduction. Substances are formed by the combination of various elements. All the elements are unique in their nature and property. To categorize these elements according to their properties, scientists started to look for a way. In 1800, there were only 31 known elements. But in the year 1865, their number became 63. Nowadays, it is 118 elements have been discovered. As different elements were being discovered, scientists gathered more and more information about the properties of these elements. Here, there are elements classified into metals, non-metals and metalloids. Here the metals, some of the elements, they have the similar properties. So, it is placed in some other places. So, in library we saw the library, the books are neatly arranged into categories and subcategories. In this way, elements to be arranged in some groups and also in periods. The early concept of classification of elements. The first one, Dobrinier triads. In 1817, Johann Wilhelm Dobrinier, a German chemist, suggested a method of grouping elements based on their relative atomic masses. He arranged the elements into groups containing 3 elements each. So, he called these groups as triads. Tri means 3, so it is called as Dobrinier triads. Then state the Dobrinier triads. When the 3 elements in a triad are arranged in the ascending order of their atomic masses, the atomic mass of the middle element is nearly same as the average atomic mass of the other 2 elements. Here come to the triad 1. In group 1, element lithium, sodium, potassium. Lithium atomic mass 66.9. Here sodium 23, potassium 39.1. So, you have to add 6.9 plus 39.1, you have to divide it by 2, that is equal to 23. So, 23 is the atomic mass of sodium. In this way, triad group 2, and here chlorine, bromine, iodine, 35.5 plus 126.9, that is equal to 81.2. Here it is wrongly printed, so you have to change this. Here element here third group, element calcium, strontium and barium. Here the atomic mass 40.1 plus 137.3. Here you have to add it and divided by 2, you can get the answer 88.7. This is also wrongly printed, you have to change this value. Then what are the limitations of Dobrinier triads? Dobrinier could identify only the 3 triads from the elements known at that time, and all elements could not be classified in the form of triads. The second one, the law was not applicable to elements having very low atomic mass and very high atomic mass. The second one, Newlands Law of Octaves. Oct means 8. In 1866, John Newlands arranged 56 known elements in the increasing order of their atomic mass. So, he observed that every eighth element had properties similar to those of the first element, like the eighth note in an octave of music. In music means sa, re, ha, ma, pa, da, ni, sa. So, here in the same way, every eighth element is a kind of repetition of the first. So, this arrangement was known as law of octaves. And come to this law of Newlands table. Here you are having hydrogen, the first group here hydrogen, lithium, then gallium, BO, and C carbon, nitrogen, N, oxygen. So, here you can, this is the Newland table. Now, what are the limitations of Newlands law of octaves? Here there are instances of two elements being fitted into the same slot. In same place you have to place the two elements, cobalt and nickel, and some elements totally dissimilar in their properties were fitted to the same group. For example, the arrangement of cobalt, nickel, palladium, platinum and iridium in the row of halogens. Halogen means chlorine, bromine, iodine, fluorine. In this place you have to place the other elements. Then the law of octaves were not valid for elements that has atomic masses higher than that of calcium, Ca. The Newlands table was restricted to only 56 elements and did not leave any room for new elements. So, no place for new elements. Then discovery of inert gases, helium, neon, argon, krypton, xenon. So, these are called as inert gases. At later stage made the ninth element similar to that of the first one. Here neon, here the neon is placed between fluorine and sodium. So, here neon has no place, and these are the limitations of Newlands law of octaves. Then Mendeleev periodic table. In 1869, a Russian chemist Dmitry Mendeleev observed that the elements of similar properties repeat at regular intervals when the elements are arranged in the order of their atomic masses. Based on this, he proposed the law of periodicity, which states that the physical and chemical properties of elements are the periodic function of their atomic masses. So, he arranged 56 elements known at that time according to his law of periodicity. And this is the modern periodic. So, this is the Mendeleev periodic table. Here group, there are 8 groups. There are 8 groups and 7 periods in the Mendeleev periodic table. So, here first group hydrogen, lithium, sodium, potassium and also copper, rubidium, silver, cesium, gold. So, this is the first group. So, this is the second group. The next one is the third group. So, fourth group, then fifth group, sixth group, seventh group and eighth group, and here some of the vacant places are placed in the Mendeleev periodic table. Now, what are the features of Mendeleev periodic table? The first one, it has 8 vertical columns called groups and 7 horizontal rows are called periods. Each group has 2 subgroups A and B. All the elements appearing in the group were found to have similar properties. For the first time, elements were comprehensively classified in such a way that elements of similar properties were placed in the same group. Then fourth one, it was noticed that some elements could not be placed in their proper groups in this manner. So, reason for this was wrongly determined the atomic masses. Consequently, those wrong atomic masses were corrected. For example, atomic mass of beryllium was known to as 14. In Mendeleev reassessed it as 9 and it is assigned by beryllium a proper place. Now come to the next one, the fifth one. Columns were left vacant places for the elements which were not known at that time and their properties also were predicted. This gave motivation to experiment in chemistry. For example, in Mendeleev gave names aluminium and silicon to those elements which were to be placed below aluminium and silicon, here respectively placed in the periodic table and predicted in their properties. After the discovery of this germanium later on during his time, it is to prove him correct. So, what some of the properties of germanium? Then property atomic mass, here atomic mass is about 75, it is corrected to 72.72, it is corrected to 72.59. Specific gravity 5.9, it is corrected to 5.47. Then color dark grey. So, the same color dark grey. Then formula of oxide ESO2 means here the germanium GeO2 germanium dioxide. Nature of chloride ESCl4, here germanium GeCl4 germanium tetrachloride. These are the properties of germanium. Now, what are the limitations of Mendeleev periodic table? Elements with large difference in properties were included in the same group. Example, hard metals like copper and silver were included along with soft metals like sodium and potassium. The second one, no proper position could be given to the element hydrogen. So, non-metallic hydrogen was placed along with the metals like lithium, sodium and potassium. Then the increasing order of atomic mass was not strictly followed throughout. Example, cobalt and nickel, tellurium and iodine. The last one, no place for isotopes in the periodic table. For example, hydrogen, the isotopes of hydrogen are protium, deuterium, tritium, but it has only hydrogen, it placed it in the first group. No place for the isotopes in the periodic table. Now come to the assignment. The first one, state the law of Dubrinian triads, state the law of octaves, state Mendeleev's periodic law, what are the limitations of Mendeleev periodic table, and these questions you have to learn and write one time. Okay students, thank you.